78 engines. That's how many Raptor 3 SpaceX needs cleared and flight ready, just to keep Flight 13 and Flight 14 on schedule. Sounds manageable, until you look at the actual timeline. McGregor is running at maximum capacity. Booster 21 isn't fully stacked yet, and NASA just made a decision about Artemis 3 they're calling risk reduction. But when you look at the data, it looks more like risk transfer than risk elimination. 3 things happening simultaneously, and they're connected in a way where if one slips, the other 2 get pulled down with it. Today we're going through each one, not to be pessimistic, but to understand exactly where SpaceX stands right now. McGregor. This week, NSF cameras captured 12 test firings at the facility, 9 of them from the main vertical stand. Burn time, 104 to 105 seconds. Consistent. Locked in. When SpaceX is developing a new engine, burn durations jump all over the place. 30 seconds for ignition testing. 200 seconds to push limits. No clear pattern. But when burn time locks onto a fixed number, that's acceptance testing. A standardized protocol, long enough to verify every parameter, short enough not to waste propellant. Bottom line, SpaceX isn't still figuring out how Raptor 3 works. They're running a certification assembly line, and that line is running steady. That's the good news. At 12 tests per week, McGregor can clear roughly 48 to 50 engines per month, if everything runs clean. No interruptions, no anomalies, no incidents. SpaceX needs 78 engines for Flight 13 and 14, 48 to 50 engines per month. 78 engines needed within 6 to 8 weeks. The math works. Barely. There is zero margin. Now let's look at those 78 engines more specifically. Booster 20 needs 33 Raptors. Ship 40 needs 6. That's Flight 13. Booster 21 needs 33 Raptors. Ship 41 needs 6. That's Flight 14. 4 batches, 4 separate deadlines. No buffer on any of them. And here's what matters most. These 4 batches can't be cleared sequentially. They have to run in parallel. While McGregor is clearing engines for B-20, B-21 engines also need to be prepped and ready to ship to Starbase the moment B-20's static fire campaign wraps, because any wait time pushes the entire Flight 14 timeline back. Think of it like running a kitchen. You've got one great chef, but only one, and you've got 4 dishes that need to hit 4 different tables at the same time. Each dish has a different cook time. None of them can be late. That is exactly what McGregor is managing right now. What nobody's covering, the actual vehicle status. Let's go through each vehicle at Starbase. Ship 40, completed cryo testing over a month ago, before Flight 12 even launched. It's waiting for rollout to Massey's for the engine test campaign. The most comfortable position in the entire equation. Ship 41, stacking completed roughly 3 weeks ago. Currently in outfitting, pressure lines, data lines, sensors being installed, aft flaps are in, thermal protection system being finalized. NSF's field team captured crews this week trimming crunch wrap, the filler material packed between heat shield tiles. Detailed work. Precise. Time-consuming. Booster 20 completed cryo testing this week. Currently being moved back to Mega Bay 1. Needs 33 Raptors installed before the static fire campaign begins. Based on B-19's timeline, the gap from cryo test to engine test campaign is roughly 4 to 5 weeks, which means if SpaceX wants Flight 13 in July, engine installation on B-20 needs to start almost immediately. Booster 21. This is the vehicle in the tightest position. This week, B-21's LOX tank was mated to the aft section, after being moved out to make room for B-20's cryo test. The methane tank still hasn't been stacked. Once stacking is complete, B-21 still needs full outfitting. COPV installation, chine installation to protect the COPVs, cryo testing, engine installation, and static fire. That's a long chain, and the timeline is not generous. The data shows. For Flight 14 to happen in August, B-21 needs to complete its entire campaign in roughly half the time it took B-18, B-19, and B-20. Not impossible. SpaceX has repeatedly pulled off things that looked impossible on paper. But this is a tight timeline, and it depends on everything running in lockstep, from Starbase all the way to McGregor. Bottleneck 2. Booster reuse isn't optional. Gwen Shotwell told CNBC that SpaceX hopes to catch the booster on Flight 14. Most coverage read that and thought, ambitious milestone SpaceX is targeting. But look at the actual production timeline, and the story is completely different. Catching the booster on Flight 14 is not an ambitious milestone. It's the minimum requirement for the 2025 schedule to hold any meaning. B-21 is running several weeks behind previous boosters. Even if everything goes perfectly from here, B-21 needs a significant amount of time to complete its full campaign and be ready for Flight 15. But if SpaceX can catch and reuse B-20 on Flight 14, the picture changes entirely. They'd have a flight-proven booster ready immediately. No waiting on B-21. And here's what's even more important. Ship production is outpacing booster production. Ship 42 has already started nose cone stacking at the Star Factory. If it tracks similar to Ship 41, S-42 could be ready by early fall. With a booster reflight instead of waiting on B-21, Flight 15 from Florida becomes significantly more viable. Flip that scenario around. If Flight 14 doesn't catch the booster, then Flight 15 depends entirely on B-21 hitting its schedule. On a pad in Florida that still doesn't have a complete flame trench, a full launch mount, or a ready tank farm, that's not a small pressure. And if you look further out, toward the goal of 800 flights per year by 2028, the math becomes even clearer. SpaceX can't build 800 new boosters every year. Physically and logistically, that's not feasible. Reuse is the only path. Falcon 9 is the proof of concept. Booster B-1067 just completed its 35th flight last week. Its first flight was over 5 years ago. SpaceX didn't build 35 different Falcon 9s to do that. They built one and flew it 35 times. That's the model Starship needs to follow, and it needs to start now. Not because it's a technically beautiful achievement to showcase, but because it's the prerequisite for every other number in SpaceX's roadmap to hold up. Every time a booster gets caught and reused instead of replaced, that's tens of millions of dollars not spent. Multiply that across hundreds of flights, and that's the funding that underwrites the entire program without reuse. The 800 flights per year chart is a fantasy. With reuse, it starts becoming a spreadsheet. Flight 14 is the first time that path can open, or be delayed further. 1. McGregor is the real controlling node of this timeline, not Starbase, and it's running at maximum capacity with zero buffer. 2. Ship production is outpacing booster production, and that gap has exactly one solution: booster reuse. 3. Catching the booster on Flight 14 is not optional. It's the requirement that makes Flight 15, Flight 16, and all of 2026's cadence work. But there's a third bottleneck we haven't addressed yet, and it's the most complex one, because it doesn't sit with SpaceX. It sits with NASA. Bottleneck 3, Artemis 3, and the risk nobody's naming correctly. This week, NASA held a press conference for Artemis 3. They announced the crew, confirmed the mission architecture, and announced a decision they're framing as risk reduction. But when you look at the actual data, I think there's a more accurate way to describe it. Here's the confirmed Artemis 3 mission structure. Orion will rendezvous with Blue Origin's Blue Moon lander and SpaceX's Starship in lunar orbit. Crew transfers from Orion to Blue Moon. They test Axiom lunar spacesuits. That's the primary mission. The Starship in Artemis 3, no crew cabin, no life support. Just a standard production ship with a docking adapter bolted on. NASA Administrator Jared Isaacman explained the rationale on the Flame Trench podcast. SpaceX already has a solid track record on rendezvous and docking. Those capabilities are proven. Artemis 3 is about Blue Moon, testing life support, testing the cabin, testing the spacesuits. That's where the most critical mission data comes from. That logic holds. I'm not disputing it, but if Starship HLS isn't flying a crew cabin with life support on Artemis 3, then when exactly does that system first fly in a real lunar environment? The answer is Artemis 4. with a real crew. On the actual lunar surface, not a test flight, not a demo. The first time, and also the time there are humans inside depending on it to keep them alive. In aerospace engineering, there's a principle that's straightforward. You don't want the first test of a system to be the moment people are depending on it to survive. NASA understands this. That's why Isaac Mann mentioned 2 uncrewed end-to-end flights that must happen before Artemis 4. Those flights will test the complete HLS system, including the cabin, life support, and lunar environment, without crew on board first. That's the right plan. But here's the question nobody asked directly at the press conference. Do those 2 uncrewed flights have enough time to complete before Artemis 4's launch window? Jessica Jensen confirmed at the press conference that the HLS cabin is structurally complete at Starbase. Hardware outfitting is the next step. Physically, the cabin is being built. Progress is on track. But from cabin is being built to cabin has been tested in the actual lunar environment twice, uncrewed, and is certified for a crewed mission, that's a significant stretch of time. And that stretch depends on exactly what we covered earlier. Flight 13 has to launch on time. Flight 14 has to demonstrate reuse. Flight 15 has to be operational from Florida. Then propellant transfer demo. Then uncrewed HLS demo, twice. Then Artemis 4. Every step depends on the one before it. And the first step, Flight 13, depends on McGregor delivering on schedule. That's not a reason for pessimism. That's a reason to pay close attention. One more Artemis detail most people aren't focusing on. There's one more announcement this week worth flagging. Technically interesting. SpaceX and NASA are studying the option of using Starship to perform translunar injection and lunar orbit insertion. Simplified, instead of Orion flying to the moon on its own, Orion and Starship dock in Earth orbit first. Starship then pushes both vehicles to the moon. Starship does the heavy lifting. Orion carries the crew. If this architecture is adopted, some clear advantages emerge. The crew could return to Earth within a day if something goes wrong, instead of being stranded in lunar orbit with no fast escape. That's a meaningful safety margin. The number of propellant transfer flights needed for Starship HLS also drops significantly, because Starship doesn't need to reserve propellant for the full round trip to lunar orbit if it's already operating there. But this architecture also adds a step to an already complex mission. Docking in Earth orbit with a vehicle the size of Starship, that's its own engineering challenge. What I find significant here isn't whether this option gets selected. What's significant is that SpaceX and NASA are looking at the mission architecture and asking, is there a safer, more efficient way to do this? In aerospace engineering, asking that question before committing is the mark of a mature program, not a sign of hesitation. But it also means certain mission architecture decisions are still being finalized, while Artemis deadlines aren't waiting. 3 bottlenecks, 1 connected chain. McGregor needs to deliver 78 engines on time, with no buffer. Booster reuse needs to happen on Flight 14, not because it's a great showcase milestone, but because the production math breaks without it. Artemis 3 is being restructured in a way that transfers risk into Artemis 4. And the question of timeline for those 2 uncrewed demo flights still has no public answer. If McGregor slips, Flight 13 is late. If Flight 13 is late, Flight 14 is late. If Flight 14 doesn't catch the booster, Flight 15 depends on B-21 hitting its schedule. If Flight 15 slips, the uncrewed HLS demo timeline compresses. If the uncrewed demos don't get enough time, Artemis 4 puts crew on the moon in a system that hasn't been fully tested in a real lunar environment. That's the domino chain. And the first domino is being held by a test facility in Texas running 104-second burn times on engine serial number SN178. I'm not saying the chain will fall. The McGregor data this week, consistent burn times, steadily climbing serial numbers, 12 tests per week. Those are genuinely positive signals. The stripped-out Raptor 3 turbo machinery spotted this week is also a positive signal. It means Raptor 3 is mature enough to have hardware with a history. You don't see that on an engine still deep in development. SpaceX is doing the right things at the right pace, but doing the right things and operating without risk are 2 completely different statements, and an honest analysis has to keep those 2 things clearly separated. What to watch in the coming weeks? If you want to assess the real timeline yourself without waiting for press releases, here's what to track. At McGregor, test cadence. If it drops below 8 per week, something is disrupting operations. If it climbs to 15 or higher, SpaceX is pushing to recover schedule, serial number gaps. If numbers jump significantly in a single week, say SN178 to SN195, more engines got cleared and shipped than the cameras captured. That's a positive timeline signal. Burn time variation. If it suddenly shifts away from the fixed 104-second mark to varying durations, SpaceX is investigating something. Pay closer attention when that happens. At Starbase, B-20 engine installation. Track the time from now until B-20 rolls out for its engine test campaign. If it exceeds 5 weeks, a July Flight 13 starts becoming a pressure point. B-21 methane tank. Watch for when the methane tank gets mated and full stacking completes. That's the earliest indicator of whether B-21 has enough time to support a Flight 14 in August. On Artemis, watch for SpaceX and NASA to release specific timelines for the 2 uncrewed HLS demo flights. If concrete dates emerge, the plan is solidifying. If it stays vague, the timeline question remains open. McGregor is the leading indicator. It tells you the real timeline before any official SpaceX announcement does. And in the weeks ahead, while everyone else is watching Starbase waiting for B-20 to roll out, I'll be watching McGregor, because that's where the real answers are being written. One final detail before we wrap. Jessica Jensen confirmed this week that the HLS cabin is structurally complete at Starbase. Hardware outfitting is next. That's the first clear, unambiguous confirmation of the cabin's status. Not a plan, not a render. Structurally complete, physically existing at Starbase right now. And it's waiting on a chain of flight tests to happen on time, so it has a chance to reach the moon.